Okay, hi guys, so let's continue on seeing more on delta RH naught and delta FH naught. So let's continue. Suppose we have some example in which carbon in solid state and which is graphite, it's getting converted into, or rather reacting with O2G and forming CO2G. For this reaction, delta FH naught, let's say for delta RH naught for the reaction would simply be delta FH naught CO2G. Okay, but on the other hand, if we have carbon solid in diamond phase and then we are reacting with O2G and forming CO2G, then delta RH naught for this reaction would not be equals to delta FH naught of CO2G, because delta FH naught for carbon or rather diamond is not equals to 0. But from previous section we can say that delta FH naught for carbon in graphite form is actually 0. Hence we can write that delta RH naught for this reaction is simply delta FH naught for CO2G. Okay, next let us see carbon monoxide reacting with half moles of O2G forming CO2G. So in this case as well, delta RH naught would not be equals to delta FH naught of formation of CO2, because carbon monoxide is not in elemental form. Okay, rather delta RH naught for this reaction would be delta FH naught CO2, this bracket is not required, minus delta FH naught carbon monoxide. Okay, so let's see some cases here. So case 1 is if delta R CPM naught is temperature dependent, rather let's say first it is temperature independent from T1 to T2. T1 to T2 is the interval in which we are interested in calculating delta RH naught value. So delta RH naught 2 minus delta RH naught 1 would simply be equals to delta R CPM naught T2 minus T1. Okay, but on the other hand, okay, so first T1 is delta RH naught 1, which is the standard enthalpy of reaction at temperature T1. Reaction at temperature T1, and delta T2 is delta R H2 naught, which is again the standard enthalpy of reaction at temperature T2. Okay, now let's see case 2. So case 2, similarly, if delta R CVM naught is temperature independent, CVM naught is temperature independent, from T1 to T2 again, so we can write delta R U2 naught minus delta R U1 naught would be equals to delta R CVM naught T2 minus T1. Or in other words, we can write that delta R E2 naught minus delta R E1 naught would be equals to delta R CVM naught T2 minus T1. Okay. Next, let's see the cases when delta R CPM naught is temperature dependent from T1 to T2. If delta R CPM naught is temperature dependent, from T1 to T2, so here we can write that a reaction in which A goes to B plus C, and here CPM naught for A, let's say, is A1 plus B1T, and similarly CPM naught for the product B is A2 plus B2T, and CPM naught for product C is again temperature dependent with A3 plus B3T. So we know that delta R CPM naught for the reaction would be equals to delta R CPM naught for product B plus delta R CPM naught for product C minus delta R CPM naught for product for reactant A. Okay, so we can write it that it is A2 plus A3 minus A1 plus, or rather we can write it like it is, okay, first let me write the B2 term. So B2 plus B3 minus B1T CPM naught, not CPM naught, directly this term. So this can be written as delta R CPM naught as A plus BT. Okay, so using the same we can write that integration of d of delta RH naught can be written as integration of delta R CPM dt, so which is A plus BT times dt. Okay, so we can write that this would be delta R, this is again from T1 to T2, so we can write delta R H2 naught, so this is from H1 to H2, so delta R H2 naught minus delta R H1 naught would be equals to A times T2 minus T1 plus B by 2 times T2 square minus T1 square. Okay, so with this we come to the end of this lecture. We'll meet in the next lecture. So till then, good luck and goodbye.